Question 1. We've been given a VT graph and its explanation is in these 5 lines. I would like you to go through these lines and pause the video to read that and then we'll continue. Okay, the first part says that given that during two stages of the motion when the car is accelerating, the accelerations are equal. Find the value of t. So it is accelerating means the velocity is becoming more and more in this period and this period. These are the two periods where it is accelerating, and they're saying that the accelerations are equal in these two periods. And we know that gradient of VT graph gives you acceleration. In other words, what they're trying to tell you that the gradient of this line is equal to the gradient of this line. So let's find the gradient of this line first. And we know the formula for that is y2 minus y1 over x2 minus x1. But here we have v and t, so we will say v2 minus v1 over t2 minus t1 will be gradient, which is acceleration. So let's write the coordinates of this part, which is 520, correct? Coordinates of this is 0, 0. So the gradient becomes 20 minus 0 over 5 minus 0, which is 4 meters per second square. And same acceleration will be here. Let's write the coordinates of this one. It will be 50, 20, and the coordinates of this point will be t6. And now we'll find the gradient of this, which will be v2 minus v1 over t2, which is 50, minus t1, and t1 is unknown to us. We'll write t, and we know it is equal to 4 because we got 4 here. And now cross multiply this. 20 minus 6 is 14 equal to 4 multiplied by 50 is 200 minus 40. So let's bring 14 to the right side and 40 to the left side. It becomes 40 equal to 200 minus 14. So 4t equal to 186. So t will be 186 divided by 4, and that will be 4 times 4 is 16. 2, 6. 4 times 6 is 24 and 0.5. So this t is 46.5 seconds, which is, yeah, very close to 50, makes sense. Let's move on to the B part, which is this. Find the total distance traveled by the car during the motion. Okay, whenever we have a VT graph, the area under the curve or area under the graph, even if it is straight, is the distance traveled. Okay, let's this be the first triangle. We'll find, do we have everything here? Yes. So we'll find the area of this triangle, which is half base. Base is 0 to 5, 5. Height is up to 20. Yeah, that is the height. So times 20, that makes it 10 after cancelling, 50 meters. In this particular triangle, it traveled 50 meters. Then we can talk about this rectangle. Okay, this rectangle. Here this rectangle is length is 5 to 25, 20 multiplied by the height is also 20. So 400 meters during this period. Now this trapezium, can you see this trapezium? We can find its area as well. So area of a trapezium, let me write it here, is half first parallel line, which is, let's take this one, which is 6. Second parallel line, which is the tall one, which is 20. We have to add them. And multiply by the height. Height is the distance between the two parallel lines, which is 25 to 35. So 26 and 2 can cancel out, 13 and times 5, 65. 65 meters in this trapezium. Okay, next we can take this rectangle again. This rectangle length is 16.5. From 30 to 46.5 is 16.5 is the length. Height is 6. So it will be 96 plus 3, 99 meters. Okay, another trapezium. Shorter length. Let's do it here. Shorter length is 6 again, and longer length is 20. We have to again multiply by half, and the height this time between them is 3.5, 46.5 to 50. This is the height between them, 3.5. That is 13 again. So 13 plus 6, 13 times 3 is 39, plus 6 is 45.5 meters. And finally we are left with this triangle. Its area will be, let's do it somewhere outside, half. Base is 10 from 50 to 60. Height is 20 again. And this will cancel here. 20 times 5, 100. So now we can write the whole distance traveled. This is V 50 meters first, then 400 meters, then 65 meters, followed by 99 meters, 45.5 meters, and finally 100 meters. That comes out to be 400, 500, 599, 649, 714, and 759.5 meters. That's the total distance traveled. Question 2. A van of mass 3600 kg is towing a trailer of 1200 kg. So let's draw a van. 3600 kg is its mass. It is towing a trailer of mass 1200 kg. Alright. On a straight line, straight horizontal road using a slight horizontal rope. So there's a rope in between. There are resistances 700 Newton on the van. So 700 Newton on van and 300 Newtons on trailer. Okay. The driving force exerted by the van or its engine is 2500 Newtons. Find the tension in the rope. Okay, tension is here. Since tension is involved, that means we have to break this whole system into two parts. So let me do it here. I will focus first only on the van. Let's do it here including tension. Okay, so the forward force is on, let me draw the free body diagram. Forward force is just 2500 Newtons. There is a backward force of 700 Newtons, plus we have tension also backwards, which is trying to pull it backwards. So we know that F net, which is equal to mass times acceleration, is applied force minus resistive force. Since they are not asking any acceleration, so let's isolate acceleration here so that I can find acceleration also of the second one, and that is the common thing between them because same acceleration is the one with which both of the bodies are moving. So I can write m is 3600 here times A equal to applied force is 2500 Newtons, and then we have 700 and minus t. There are two forces which are in opposite direction. So acceleration will be 2500, 1800 minus t over 3600. We cannot cancel 1863,600 because there's a negative here. With a negative, we can't. So we have isolated acceleration here. Similarly, let me draw a free body diagram in this direction also, this second body trailer also. So the forward force for this is only tension. Tension is part of both, okay? So tension is the one that is carrying it forward, but there is a backward force of 300 newtons, and these are the only two forces. So let me apply the same formula there. F net is m, mass is 1200, times acceleration equal to applied force, in this case is tension, which is bringing it forward, minus 300. So acceleration is t minus 300 over 1200. Since this acceleration is same for both, we'll equate them now. So let's equate. Equal to t minus 300 over 1200. So let's get rid of 1200. Multiply this by 1200 here. Multiply this also by 1200. So this 1200 and 3600 cancel, and they cancel completely. We are left with 1800 minus t over 3 equal to t minus 300. So let's cross multiply 3 to the other side. 1800 minus t equal to 3t minus 900. And let's complete it here. 1800 plus 900 equal to 3t plus t. 2700 equal to 4t, and t will be 2700 divided by 4. That should be 675 Newton. This is the tension they are asking. Okay, the next part. The driving force is now removed and the van driver applies a braking force which acts only on the van. Okay, so this is van. There is no driving force, only resistance force, 700 newtons, and there will be a braking force. Let's call it FB. Okay, and now the resistance forces remain unchanged. Find the least possible value of the braking force which will cause the rope to become slack. That means there is no third force of tension anymore because the rope between the van and the trailer is slack. That means there is no tension. Tension equal to 0. It also means that the deceleration of van in this direction will be more than the deceleration of trailer, right? So the minimum force, they're saying minimum force, we need least possible force. That means we'll make them equal and then we'll say that that is the force when it'll start slacking. Okay, so now this is our new free body diagram, so we can write what is the acceleration in this case. So 3600 was the mass of van times acceleration ma equal to, there is no applied force, we have just 700 and fb. So acceleration in this case becomes minus 700 minus fb over 3600. All right, similarly we'll do for the trailer. Now there is no tension, so there is no applied force for trailer as well. There is only a force backward which was 300 newtons. So it will be minus 300. First let's write this mass. 1200 A equal to minus 300 Newton. Okay, so acceleration is minus 300 over 1200, which is minus 1/4. So this acceleration has to be at most minus 1/4. So we'll write equal to minus 1/4, and that will give us the least value of FB. So let's cross multiply. 4 times 700 is minus 2800 minus 4 FB equal to minus 3600. Okay, And now let's keep minus 4b on the left side, but take 2800 to the other side. 3000 minus plus 2800 minus FB will be minus 800 divided by minus 4. Cancel. So 200 Newton is the minimum braking force we need so that the deceleration of the van becomes less than the deceleration of trailer, and that's why the tension will become zero and the rope will slack. Question 3. The diagram shows a semicircular track ABC of radius 1.8 meters which is fixed in a vertical plane. Okay, this is the vertical plane. A and C are at the same level. B is here. Okay, the section AB is smooth, that means there is no friction. Section BC is rough. BC is rough. Okay, there's a friction here. So a small block is released from rest from A. So this block is released downwards. Okay, show that the speed of the block at B is 6 meters per second. So we can clearly see that because this point A is at a height 1.8 meters above B, that means it will have more potential energy, and its potential energy with reference to this bottom will be mgh. Mass is unknown, g is 10, height is 1.8 from B, so that becomes 18 m. All right, when it is starting, its velocity is 0 because they're saying it is being released from rest. So its kinetic energy is 0 here, and when it reaches, it will have its maximum kinetic energy. So what will be the kinetic energy? Half mv square will be the kinetic energy. Mass is unknown and velocity we have to find, but that kinetic energy came 100% from potential energy because there is no friction in between. So we can write 18m equal to half mv square. M and M cancel. 2 multiplied with 18, 36 equal to v square, square root both sides. V comes out to be 6 meters per second. That's what we need to show. Okay. The block comes to instantaneous rest for the first time at a height of 1.2 meters above the level of B. Okay, so let's get back the drawing here, and they're saying that after B it reaches to a height of 1.2 meter above B, 1.2 meters. Obviously, because this surface is rough, so it will not reach up to the same level. And the work done against resistance is 4.5 joules. Alright, so the formula we should remember is this: change in kinetic energy plus change in potential energy is always equal to the work done by the applied force minus work done by the resistance force. Since we just released this particular block from A, and there was no one touching this block till it came to rest here, so applied force is nothing in between, so this is 0. Resistance force, the work done by it is 4.5 joules. They have given that, so we will write here. Now the potential energy was 0 at this particular position. With respect to B, it was 0. So change in potential energy will be wholly because of the height gained after that, which will be m, g, and h is 1.2, which is 12 m. That is the change in potential energy, and it is positive change. Why? Because it is gained. Potential energy is gained, but kinetic energy is lost. So delta Ke, it was half m and v square. We got v earlier equal to 6 in part A minus 0. Why? Because it stopped at this particular position, so velocity is 0. That's why kinetic energy is 0. So whole of this will be this. which is half, and let's me write here, half times m times 36 cancels 18, which is 18m. But this will be negative. Why? Because it is lost. So negative 18m is the energy, kinetic energy lost. There's change, to overall change will be minus 6m equal to minus 4.5 m. Mass of the object is minus 4.5 over 6, and that will be 0.75 kg. Question 4. A cyclist starts from rest at a point A. Okay, so here V is 0. Obviously S is also 0. And goes towards B. Coming to rest at B also. So here also V is 0. And this point is B. The displacement of the cyclist from A at time t seconds after start is s meters, and it is given by this one. So this is the displacement. Okay, so show that the distance from A to B is 250. Since here is velocity 0 and then it is coming at rest here, that means it is turning back from here. There is no turning point in between, so we can say displacement is equal to distance, right? So we can use this, but only problem is that we don't know at B what is the time. So to find this time, if we find time, we'll just substitute here and we'll get displacement and distance. So to find this turning point, we'll have to find the velocity equation from displacement equation. And velocity is nothing but the differentiation of displacement equation. And if we differentiate this one, 0.004 is a constant, so we'll not touch it, we'll just differentiate what is inside here. So 2 times 75 is 150t minus 3t square. Alright, so at turning point when velocity is 0, we'll have to make it equal to 0. So 0 equal to 0.004 150t minus 3t square. We can further factor this part also. So we can write 0.004 times 3t, and here we are left with just 50 and minus 1t. That's it. And why did I factor? I wanted to get the values of t when it is 0. So this gives us, okay, this does not give us anything, okay, it's a constant, it can't be equal to 0. So we'll write 3t equal to 0, and at t equal to 0, v is 0, and we know that it is 0. So we already knew this answer. It is useless for us. Now this one, 50 minus t equal to 0, and that gives us t equal to 50 seconds. This is the one which is useful, and we'll just substitute this 50 into this equation, and we should get our distance or displacement. So it will be 0.004. We can write here s at 50 seconds. 75 times 50 square minus 50 cube. Okay, so that becomes, let me use my calculator to find this. By the time I find it, I request that you please like this video and share with your friends so that such quality videos come up in the future too and you get benefited. And yes, after I used my calculator, it gave me 250 meters. Find the maximum velocity of cyclist. Okay, so since these are the two turning points where the velocities are 0, the maximum will be somewhere else. And like we find the maximum and minimum point for any function by differentiating it and finding it turning point or stationary point. We have to find the stationary point of velocity, not displacement. Why? Because we are asking maximum velocity. So that means whatever we got, we have to differentiate it again so that we get acceleration. So acceleration is differentiation of velocity, and that will be 0.004. I'm focusing here. This is velocity equation now. This one. I will differentiate it again. So again, this part is constant. I don't touch it, but I will differentiate what is inside. 150t, its differentiation will be just 150 minus, here it will be 60, rather 6 and t. And now we have to make it equal to 0 to find stationary point. So to make it equal to 0, 0.004 cannot be equal to 0, so this is the only one. 150 minus 60 equal to 0, 6, so the t equal to 150 over 6 if I bring 60 to the other side, and that gives us 25 seconds. At 25 seconds, we will have either maximum or minimum velocity. But we have just this turning point, that means obviously it will be maximum, but we'll verify it later. First, let's find the maximum velocity by substituting 25 into the velocity equation, which was here again. So it will be velocity equal to 0.004150 times 25 minus 3 times 25 square. And after using my calculator, I got 7.5 meters per second. This is the maximum or minimum velocity. Though we know 0 meters per second is minimum, but maybe a negative velocity would be even lower than that. So let's confirm if this is the maximum velocity. For that, what do? We find second derivative. There is nothing beyond acceleration which gives us rate of change in acceleration, but we will still do to find the nature of the stationary point, and we will differentiate this again. So it will be 0.004 remains what it is. 150, the differentiation will be 0, so we will not write it. Just differentiation of this will be minus 6, and we can clearly see that it is coming out to be a negative. And whenever the second derivative is negative, it is a maximum value. So it is a maximum velocity confirmed. A railway engine of mass 75,000 is moving up a straight hill incline at angle alpha. So let's draw this. Angle is alpha and it is moving up. Its weight will be 75,000 and multiplied by 10. This is its weight. Okay, where sine alpha is 0.01. The engine is traveling at a constant speed. That means acceleration is 0. And it is 30 meters per second throughout the speed. The engine is working at 960 kilowatts. So power is 960 kilo. 1, 2, 3. 1000 watts. Okay. There is a constant force of resistance, okay, to the motion of the engine. Find the resistance force. Okay. Since acceleration is 0, that means whatever is the force applied will be same as the resistance force. So one resistance force is already known to us, which is the force because of gravity, and that will be 75, 1, 2, 3, 4 zeros and sine alpha. This is the force which is the component, y component of this weight in downwards. There are two forces which are bringing it down, but there is an applied force upward by this power. And we know that that force applied is power divided by the velocity. So power is 960,000 over velocity is 30. So we can cancel this and it becomes how much? 32,000 newtons. That's the applied force. So 32,000 upwards and same will be downwards. So 32,000 equal to 750,000 sine alpha plus r. And this key idea behind this is acceleration, because acceleration is 0. So ma will be 0, F net is 0, right? And because F net is 0, so the force upwards and downwards both are equal. So let's find R now. R is 32,000 minus 750,000, and we can write the value of sin alpha now, which is given to us 0.01, and we can find by using our calculator, and my calculator gives me 24,500 Newton is the resistance force. Okay, the B part. The engine comes to a section of the track which is horizontal, now no hill. At the start of the section of the engine traveling at 30 meters per second, okay, and the power of the engine is now 900 kilowatts. 900 kilowatts, okay. The resistance to the motion is no longer constant, okay, it is variable. But in the next 60 seconds, work done against the resistance is this. So if from here to here is 60 seconds time, total work done by resistance against resistance from here to here is minus 46500 kilojoules. Okay, kilojoules. Okay, find the speed of the engine at the end of 60 seconds. Means what is the speed here? So we can know that delta PE, then difference in potential energy, plus delta KE equal to the work done by the applied force plus rather minus work done by the resistance force. This negative I've already written here, so I will write negative. So since it's a horizontal track, there is no change in potential energy, the height remains same, so it is 0. The difference in kinetic energy will be half m final velocity minus initial velocity square. This is the difference of kinetic energy. Applied force will be, let's find it again, applied force. This is our power. So we want to find the work done. So work done will be power multiplied by time. So power is 900, 5 zeros. Okay, multiplied by 60 seconds. 9 times 6 is 54 and 6 zeros. 1, 2, 3, 4, 5, 6. This is the work done by the engine. So we'll write this here. 54 million joules, and minus work done by total work done by against the resistance during this period was how much? 465 and 1250. 4 6 5 1 2 3 4 5 zeros. Okay, so everything is known to us, even mass is known to us. Only thing left, and even velocity, initial velocity was 30 meters per second, that was given to us, so we can use that one also. So everything is known except for the final velocity, and we can find it. Let's substitute. Half the mass of the train was 75,000 kg. Vf we don't know. This we know, 30 square equal to, and if we subtract this we get 75, 1 2 3 4 5. All right, so let's do cross multiply by multiplying this by 2 and dividing by 75,000, so that we cancel these two. Same thing has to be done here. 2 divided by 75,000, so we can see that this and this is 100. Okay, so this is also cancelled. Vf square minus 900 equal to 200, and Vf square equal to 200 plus 900, which is 1100. We can square root both sides, and this comes out to be 33.2 meters per second is the velocity after 60 seconds. In the question 6, a block of mass 5 kg is held in equilibrium near a vertical wall, this is the wall, by two light strings, okay, and a horizontal force of x newtons, as shown in the diagram. The two strings are both inclined at 60 degrees to the vertical, okay. Given that x is 100 newtons, find the tension in the lower string, okay. If this 5 kg mass was not there, then it would be easier. Both the tensions would be equal. But because of this 5 kg, they will be different. So let's name them T1 and T2. And we have to find T2. So let's draw the components of the forces here. So the force upwards will be, since this is 60 and this is 60, this third angle will also be 60. That's how it will make 180 degree for the triangle. And that means if I divide a horizontal line in middle of this, the upper angle will be 30 degrees and the lower angle will also be 30 degrees. And that's why the component of T1 in this case will be T1 cos 30 degrees here. And T2 will also have a component here which will be T2 cos 30 degrees. Okay, now the upper component of T1 will be T1 sine 30 degrees and the lower one will be T2 sine 30 degrees. Now the two inclined forces T1 and T2 are taken care of. They are divided into components and 100 Newton is already there. So let's, because the system is in equilibrium, let's equate the vertical forces. Because of equilibrium, it will be like T1 sine 30 will be equal to T2 sine 30 plus there is a weight of 5 kg downwards, so it will be 50 newtons downwards. So we have to add that force also with T2 sine 30. That's why they will be unequal. And sine 30 is half, so we can write it as 0.5 T1 equal to 0.5 T2 plus 50, or T1 will be 0.5 T2 plus 50 divided by 0.5. So now we will eliminate T1 because we don't want T1. They're asking us the tension in the lower string, which is T2. And we will write in terms of T2 in the second equation. And second equation is because of the horizontal forces. Let's write them. T2 cos 30 plus T1 cos 30 will be equal to 100 newtons. And since we have the value of T1, we'll substitute it. So it will be 0.5 T2 plus 50 over 0.5, and then we have cos 30 after that. Cos 30 is square root 3 over 2 plus T. Okay, I did this one. Both are cos 30. So because T1 is here, so just assume that this is this part, and I will write this part now, which is T2 and multiplied by square root 3 over 2 again and equal to 100. Now T2, let's separate this. 0.5 T2 over 0.5 multiplied by square root 3 over 2, this one, right? Because it is multiplying with whole of it. So when we separate them, they will be just like that. 50 divided by 0.5 and again square root 3 over 2 plus, they cancel out. Okay, it becomes a little complicated, but no problem, just keep your cool, everything will be okay. Okay, equal to 100. This and this will also be 100. Okay, and 2, okay, 2 and 100 can cancel. Wow, so it becomes easy now. Let me move this B part down to make some space. Okay, so it becomes square root 3 over 2 T2 and square root 3, both of them are same, so 2 square root 3 over 2 T2 is the combination of the two. This is 50 square root 3, which we'll take to the right side. 100 minus 50 square root 3. 2 and 2 cancel. So T2, which they asked us, is equal to 100 minus 50 square root 3 over square root 3. Now let's use our calculators to just quantify this. By the time I do that, please like and subscribe to this channel and motivate me to make more videos like this and help you in understanding concepts. And when I put all this in my calculator, I got almost 7.74 newtons. That's the tension in lower string. Yes, what was the second part? Find the least value of x for which the block remains in equilibrium in the position shown. So let me try to explain this to you. What they mean is that we have 100 Newton force on this side here. If we make it 99, this string will still be taut. It will be tight. And if we keep on reducing it 99, 98, 97, there will be a value of force when this will start wilting. These ropes will become not tensionful, and that is the least force we need. And whenever a string becomes wilted like this, or I mean it's hanging, just hanging, that situation we say that tension is zero. Just like the question number 2 of this question paper, we had a case when trailer and van had a rope in between, and we said that tension is zero because the rope is not having tension anymore. So this is what we'll do. Because of in place of this 100, we have to find some force x. So let's change this one here. So let me copy this whole equation and then I'll make it understandable. Okay. Okay, it is here. So I have copied the same position. So equation will still remain same, only change will be that the tension will become zero. So this was the equation I reached at, and we simplified this to here. So it became square root 3 T2 equal to, and now 100 is not there anymore. In place of 100, there is x minus 50 square root 3. And we want a situation when T2 is about to become a wilted rope. So no tension in this, so it becomes square root 3 times 0 equal to x minus 50 square root 3, and this is 0, so 50 square root 3 comes to the left side, and that is the value of uh, x, which will be about 86.6 newtons. Okay, so the concept should be very clear to you. The least force, as they are saying, will be the one which will just make that tension exist, and that's how it will be this. In question 7, they have given two particles P and Q. One has a mass 2m, the other one has a mass m. One is let go down, that means it was at rest at the starting, so u is 0 for this. This one was projected upwards by speed of 10 meters per second. This surface is rough and the coefficient of friction is 0.6. The angle is alpha for the inclined plane and sine theta is 0.8. We will use it whenever needed. A part says show that acceleration of q up the plane is minus 11.6 meters per second square. That means particle p is of no use. We'll just focus on q. And let me draw it a little cleanly here, because if I draw there, it will be a little complicated. So let's do it fresh here. So this angle is alpha, and this is the particle. Its mass is 2m. That means its weight will be 2 times 10, 20 m. That will be the weight. The x component of this weight will be 20 m sine alpha. Please, if you don't know how this component is 20 m sine alpha, you can scan my channel and see how this comes out to be sine alpha all the time. Similarly, there will be a x component in this direction, which will be 20 cos alpha, and exactly same upwards, which will be the normal contact force, 20 cos alpha. This is the normal contact force. Okay, our job is to find the acceleration of q up. So let's find its net force first. F net, which is mass times acceleration, equal to applied force minus resistive force. So what is the applied force? There is no force that is forcing it up. It was thrown at the initial point, and after that nothing is touching it. Once nothing touches any point, the applied force becomes zero. There is no applied force, and that's why we will not have any arrow in this direction. Though it is moving in this direction, but there is no applied force, zero. The resistive force is 20 m sine alpha. So 20 m sine alpha, this one, sine alpha they've given 0.8. And friction will also be downwards, because the object is moving upwards, the friction has to be downwards, and which will be mu r. So minus mu is known to us 0.6, they have given between the particles and the plane, 0.6, and r we just found 20 cos alpha, 20 cos alpha. Now the problem here is we have to find cos alpha as well. So there are so many ways of doing it. The easier one would be this one. I draw a triangle. This is alpha. Sine alpha, which is opposite over hypotenuse, is 0.8. That's they have given. 0.8 can also be written as 4 over 5, isn't it? If I convert it to fraction, it will be 4 over 5. So this will be 4, this will be 5. And by Pythagorean, if I use Pythagorean theorem, let's call it, do we have x anywhere? No. So let's call it x. So x square plus 4 square equal to 5 square. That means x square equal to 5 square minus 4 square, square root both sides, and you'll get it equal to 3. So now we want to find cos alpha. And cos alpha is adjacent over hypotenuse, 3 over 5, which is 0.6. And that 0.6 we can use in place of this cos alpha. So let's write this equation again. So m, mass, is not mass actually. For this particle, mass is 2m. So we will use 2m. Acceleration we have to find out, equal to minus 20 times 0.8 will be 16. 0.6 times 20 times 0.6 will be 7.2 m. There is m also. I did not write m here. We need to write 20 m cos alpha. That was the normal contact force, because the weight is 20 m. So it has to be 20 m cos alpha. That was a mistake. I've corrected it. Alright. So now we can cancel m from all three because all of them have m, so we can divide the whole equation by m. That cancels this m. So we are left with 2a equal to minus 16 minus 7.2 will be minus 23.2. And let's divide both sides by 2. We get a equal to negative 11.6 meters per second square, and this is what they wanted us to show. Let's go to B part. Find the time for which the particles are in motion before they collide. That means these two particles will collide. Alright, so what we can do here, let me assume they collide here, somewhere here. The distance from here to here, let's call it y. So distance from here to here will be 6.4 minus y, right? Because total distance is 6.4, I assume this distance to be 6y, so this will be 6.4 minus y. And let's write the equation for the one where we know acceleration already, the lower one. So we know that s is ut plus half at square. S for the particle which is going up is 6.4 minus y. This is what we have assumed, equal to, it was thrown at a velocity of 10 meters per second upwards. Time we don't know, plus half acceleration we just found out, minus 11.6 opposite to the direction it is going, t square. Okay, so let's leave it like this because we can't simplify anything except for this. We can cancel this, minus 5.8. So let's keep it. Now we'll have to work similarly the way we found the acceleration of the particle q. Same we have to do for particle p as well. So let me draw it again. This time the mass of the particle is m, so its weight will be 10m. This will be the component of its weight, 10m sine alpha, and reaction force same way like earlier will be 10m cos alpha. Alright, so let me separate this from here. So ma equal to applied force minus resistive force. M is m this time, A is unknown. Applied force will be this one because this is the one which is making it go down. No one is pushing it down. It was just let go and it started coming down. So we will write this as applied force, 10m sine alpha. Resistive force will be the friction because there is a friction between particle and the surface again, and the same 0.6 is the mu and r is 10m cos alpha. 10m cos alpha. Okay, ma is ma, 10m is 10m, sine alpha is known to us 0.8 minus 0.6, 10m, and cos alpha is also known to us now, 0.6. That's what we found in previous part. Alright, so ma equal to 10 times 0.8 will be 8m minus 0.6 times 0.6 is 0.36 times 10, 3.6m. Okay, so all three have m. We can again cancel them out. A becomes 8 minus 3.6, which is 4.4 meters per second square, positive downwards. Now we have the equation for the second particle, which is P. So let's write the equation for that one also. We had the equation for the first particle, this will be the second. The distance traveled by particle P is y. That's what we have assumed before colliding. It comes from here till here, it collides. So y distance was covered. Alright. So same formula will be used. Y equal to u is 0. It was just let go, it was not pushed, plus half Acceleration we just found out 4.4 and t square. So y becomes, this can cancel with this 2.2. 2.2 t square is the distance y. I'm saying distance, not displacement. The direction of motion of particle P is opposite to the direction of Q. But since they are the distances only, y was a distance, I will not change the sign of y. And now I will substitute this y here. So let me write equation 1 again. 6.4 minus y is 2.2 t square now equal to 10t minus 5.8 t square. Now let's put everything to the left side so that it becomes a quadratic equation. So 6.4 minus 2.2 t square plus 5.8 t square minus 10t equal to 0, and this will make it 3.6 t square. Then we have minus 10t and then plus 6.4 equal to 0. Now we can find the roots of this quadratic equation by using our calculators. When I use my calculator, I get 2 times t1 equal to 1 second and t2 equal to 1.78 second. Since they have collided at 1 second, there is no chance that they will collide again. So this time is invalid. We will just take 1. And that will be our answer. The question was, find the time for which the particles are in motion before they collide. They are in motion for 1 second. Let's move on to the C part. The particles collide on impact. They become one body. Find the speed of the combined particles immediately after impact. So, we should know that one particle was going down, right? And one particle was going up. So just before collision, what was the velocity of P particle and what was the velocity of Q particle? That's what we should know so that we can find their velocities after collision. So let's find V1 first, which is the particle P's velocity just before collision will be U plus AT. Alright, for particle P, there was no U. It was just let go 0. Acceleration we just found out 4.4. And time we just know that it was 1 second. So V1 is 4.4 meters per second downwards. Now we'll find V2. U is 10 upwards, but the acceleration is minus 11.6 and time is 1 second. So V2 comes out to be minus 1.6 meters per second. And since minus is the direction of acceleration, which is downwards, that means this is also downwards, right? Be very careful. Let me take some time to explain this. We took V2 as positive, so its U was also positive. Acceleration was downwards, that's why it is negative. And in 1 second, we got V2 equal to minus 1.6 meters per second. That means the particle P came down. Before that, it reached its highest position and turned back, and it was also coming down when they collided. That's what it means. Minus 1.6 clearly shows that it is in the direction of the acceleration, and for Q, acceleration is downwards. It is slowing down. Okay, so that is a very key idea here, because we will not use minus. Since it is also going down, it is also going down, we will give both of them, will give plus 1.6 meter per second here also. Both of them have same direction. So now M1 U1 plus M2 U2 equal to M1 plus M2 V. Yeah, this is the formula when two particles collide. So M1, let's say this is M1. So M1 is mass is just M. U1 we got 4.4 meters per second downwards, plus M2 is mass is 2M. and its velocity is 1.6 meter per second, also downwards, equal to m1 plus m2. So m plus 2m, and v is the final velocity they have. Okay, so this becomes 4.4m plus 2 times 1.6, 3.2m equal to 3mv. M cancels again. That means throughout this question, mass had no role. So it will be how much? 7.6 equal to 3v, and v equal to 7.6 over 3, which is 2.53 meters per second. This is their speed, and because it's positive, we took downwards as positive. That means this velocity is downwards. They're not asking any direction because they have used the word speed, so we will say speed. But this concept was very clear. Keep in mind why we took it as positive.